Right, we're going to be looking at some histograms today, and the idea is we're going to look at the basics and then we're going to look at two exam questions at the end. So first thing to remember is that the area is proportional to the frequency on histograms. Now generally that means that the area, which is going to be the frequency density times by the class width, will equal the frequency. So we can work out the height of the bar, which is also called frequency density. That can be worked out by doing the frequency divided by the class width. I'm just going to use CW for class width. Okay, so frequency divided by class width. And the class width is how wide is the class. Now this class from 30 to 35 is 5 wide. The frequency is 15. So therefore 15 divided by the 5, the column for frequency density for this question will give me 15 divided by 5, which is 3. And you can see that frequency density is 3 high. So this one, the area is equal to the frequency, not proportional. It's not a multiple. It's just 1 times it. But sometimes you'll get questions where it's a multiple of the frequency, and you have to be careful to realize you scale that. So therefore, if we're consistent, they've done all the bars. We've just got to work out the 50 to 71. So we notice that our method's working to get the right frequency density for the first bar. We can just test it for another one. So here we go. We've got 15. Is the class width, and we divide 15 by 15, we get 1, and the height's 1. So this one, the class width is 20 and the frequency is 55. So therefore the height of the bar is going to be 55 over 20. Divide both by 5, you're going to get 11 over 4. 11 quarters, so it's 3 quarters. Okay, 11 over 4. So 2 3/4 is going to be my height. So it's going to go all the way up to here. And this will be my bar in there. Okay, so that is how to complete a histogram for data in a table. Okay, now we're going to do the reverse. We're going to complete a frequency table from a histogram. Now, Liam collects the lengths of 190 animals and represents the data in the histogram below. Now, I'm going to just assume that they're going to be, it's a simple one from this Dr. Frost K624. So the area will give me the frequency. So this, if this is 50, then obviously this will be 20 wide. So 20 times 3 will give me 60. And this one is only 15 wide, so 1 times 15 is 15. This one is also 20 wide, so 20 times 2 is 40. And this one is 20 wide as well, so 20 times 0.5 is 10. So this one here is 20 wide and it's 2.25 high, so that's going to give me 45. This one here is 10 wide and 2 high, so that will give me 20. So my frequencies are 60, 15, 40, 10, 45 and 20. And we can check we got it right, and we got the 190, so they got 5. That's going to give me 10. So that's 30, 70, 80, 12. That's 190. So I've got the right total. Right, Lizzie collects the running times of athletes and represents them on the histogram below. There are 20 athletes at a time between 75 and 90 seconds. Estimate how many athletes have a time between 50 and 60. So between 75 and 95, so 75 and 95, we have 20 athletes. So we call this 20 wide, okay? Then the height of this bar must be 1 to get me an area 20. Yep, I've got something times by 20 must give me the 20 frequency, so something must equal 1, the height of the bar. And once you've done that, you can then put your scale in. So that's 2, that's 3, and that's 4. This is my frequency density on here, and that gives me my frequency density for this bar. Now we want to find out how many athletes are between 50 and 60 seconds. So between 50 and 60 seconds, that's 10 wide. It's 2.5 high, so it's going to be 10 times 2.5, which equals 25 athletes between 50 and 60 seconds. Right. So Lloyd collects running times of some athletes and represents the data on the histogram drawn below. And we're told there are 40 athletes with a time between 100 and 110. So this bar is 40 as an area. And we know that its base is 10, so that means this is going to be our height 4. Okay, so we can scale that. So scale that, we get 1, 2, 3, 4, 5. And so therefore this one is 15 wide times 1 is 15. This is 5 wide times 4 is 20. 5 wide times 5 is 25. 5 wide times 4 is 20. And this one is 10. 15 wide times 3, which is 45. So the total is equal to 15 plus 20 plus 25 plus 20 plus 40 plus 45. That gives me 85. That would take me to 100, 120, 140, 165 athletes. Okay, is the total number, including Lloyd's data. Right, we're going to look at a couple of exam questions now. This one's a straightforward one. We basically only have to draw the histogram. So we need our frequency density. And remember, the frequency density is equal to the frequency divided by the class width. So frequency divided by class width will give me 2. 40 divided by 20 is 2. 90 divided by 30 is 3. 140 divided by 50 is 2.8. 140 divided by 200 is going to be 0.7. And I've got 40 divided by 50, which is 0.8. So doing this on here, they've got the frequency densities already marked in. So up to 20. And 20 is going to be about here. We've got a frequency density of 2. Okay. Up to 50, we've got a frequency density of 3. And then we've got 2.8 is 50 to 100. So 2.8 is about here. 50 to 100. Sorry about not using a ruler. They go 0.7 from 100 to 300. So 0.7 is 3 down, and we're going to go from 100 all the way up to 300. And then we've got 0.8 for the last 50 here. And that's our histogram for that. Now, this is the really tricky ones that you get, so do pay attention. So let's just zoom in a bit and make it easier to see. So we got a histogram which has the birth weights of some babies. 6 of these babies weigh less than 2.5 or greater than 4. So this area here plus this area here must equal 6. Must equal 6. So those areas must equal 6. Now the easiest way, I'm just going to rub them out again so it makes it easy for me to count the squares, is to do it by counting squares. So we can see this is 4 high by 5 wide, so that's 20 squares. And this is 1 by 10, so that is another 10 squares. So we have 10 squares is equal to 6. So it's 30 squares equals to 6. So there 30 squares is 6. 1 is going to be represented by 5 squares. Okay, so the area of this one is also 20. So if the area is 20, let me just put that. So the area equals 20. So therefore, if 5 squares represents 1, this one will represent 4. So that will represent 4. And this one must also represent 4. And therefore, this one we calculated earlier must represent 2. So let's put those 2 in. And this is 4 wide by 10, 20. So this is 4 by 20. So it's 80 is our area there. Divide that by 5 will give me 16. This is 2 by 25. So that's 50. Divide by 5 will give me 10. And this one is 4 wide by 15. So that's 60. Divide by 5, that will give me 12. So my total number of babies, I want to work out the babies between 2.5 and 4 kilograms from here to here. So this is going to be, so my number of babies will equal 4 plus 16 plus 10 plus 12. So that's 20, 30. That's going to equal 42 babies. Okay, between this weight 2.5 and this weight here 4 kilograms. So do remember the frequency density, and I could have put a scale on here to work it out, but counting squares is another easy way of doing it, just to show you an alternative method.